So the idea was we were going to have a conversation now, thank you, Clive, about prospecting in general, to understand a bit of it, what it is, why we need to do it, and what the opportunities are. I wanted to start, as I've got the mic, to talk a little bit about what's happening in ESA. So first of all, prospecting is, I think, an essential thing because it creates the knowledge that underpins everything we're talking about. So we hear a lot here, and I said this yesterday briefly in the regulatory session, but we talk about technology, we talk about space architectures, business cases, and regulation. And what's missing, underlying a lot of that, often is a solid knowledge base about what's actually there. And so prospecting is about creating some facts that we can all build upon, rather than hypotheticals and guesswork, which is a lot of what's going on today. So it's kind of a fundamental step. Something that's happened in ESA, in our exploration program in the last months, is a big change where we're now focusing on exploration enabling science, or exploration focused science, we're calling it, where resource exploration is going to be a really important part of that, where we want to understand what resources are there, what their properties are, and what it might mean to use those responsibly at some point in the future. One thing that you're going to, actually, so maybe before that, there are some projects we have now. You heard about Prospect yesterday. So Prospect is a package, it's the most comprehensive package in the world today for looking at resources in situ on the moon. It's going to drill, sample, in the polar regions. It's a partnership with the US, flying with Intuitive Machines Mission 4, the end of 2027. It's going to sample potential water ice in the lunar polar regions, transfer it to a chemical laboratory where we'll do a comprehensive analysis of it, and also perform in situ resource utilization process experiments using hydrogen reduction, just to show that that can be done. And I think that'll be the first sort of hydrogen reduction or reduction process performed on the moon. We're also working with Japanese partners on their LUPEX rover. We have a number of other projects looking at potential new orbital measurements with partners in the next years too. So this is becoming a really important part of our program. Something I wanted to draw your attention to, which you may have heard about briefly yesterday, is a call that opened this week, which is a call for evidence for regions of interest for a European lunar surface robotic infrastructure. So something that we are now looking at, we are investing in infrastructure elements. We're looking at places on the moon where we might want to concentrate our efforts in terms of power, mobility, robotics, and resource exploration. And we're looking to the community to tell us where they think the important places are and why they're important. We're going to take that information, we're going to process it, identify some potential example regions of interest that we can focus on for now, and take lessons about how we're going to choose where to put our infrastructure on the lunar surface in the next years. So that's, I think, a really important thing that's happening right now. I would encourage you to get involved. So with that, I'd like to introduce all of our panel members. For those who didn't see them already, your names are up there already. Very good. So Abigail, Carlos, Antonino, that's me, ignore me, I'm here, and Clive, you've met him. We're going to talk to us a little bit about resource prospecting. And so I would like to begin, please, with Clive. You've talked to us a little bit about prospecting there and why you think it's important. Maybe you could remind us, what is prospecting in summary? Why is it important? Why is it something that we need to do now? And can you give some examples of missions that are prospecting missions now, and where you see the opportunity that you alluded to during your talk earlier?
Okay, that's how long you got?
You have 2 minutes.
Oh, okay. LUPEX would be a prospecting mission. Prospect would be a prospecting mission if it could land in the right place. Hopefully it will. I don't know where the landing site is these days because I've forgotten. But these are ground truth to orbital data sets. And the one point of ground truth we have is L-cross, impacted into Cabeus, 5.6 plus or minus 3 weight % water. And that's our one point of coarse-grained ground truth. What we need is mobility. We need cheap mobility missions to be able to go into these areas where polar volatiles are. That's non-trivial because they're very cold. And if you go to those big PSRs, Shackleton Crater, you're going down a 30+ degree slope for 4.5 kilometers into 20 to 60 Kelvin temperatures and total darkness. It's pretty hostile. So that's why we went with the smaller PSRs, and with mobility on the South Pole lunar surface, you'll be able to get into those. But there are other resources out there, some of which, and we heard from Gary Lai this morning about helium-3. There are also rare earth elements, rare earth metals that we know are in much higher concentrations than we actually have in the sample collection. And we know that from lunar prospector data, very coarse-grained orbital data, requires ground truthing. So understanding the reserve potential of lunar resources is what prospecting does. There are no reserves because there's no economic value to them. We have to make assumptions about that. But if we show the grade of the ore body, that then starts to create the possibilities that this is something useful. If we show that we can extract it, we can get to it, we can refine it. So in situ resource utilization can become a reality. Without those data to point where to put those pilot plants and where to put those tech demos so that you can do that in situ, that's what prospecting does. It basically tells you where to go. And that's what we need. We have an idea in a sort of regional sense from remote sensing. Now we need to get down to the less than 10 meters, maybe 1 meter type, and look in 3D as well. We've got tantalizing data from orbit in 3D. We need to ground truth that, and that's what prospecting needs to do.
Thanks. So most of the missions that we see being planned today looking at prospects, so you talked about prospects, you talked about EMS LUPEX, a lot of what's going on. Look at the entire Artemis program are all focused around the South Polar region, driven in large part by the potential for polar volatiles, water ice, which is a really simple story to tell, right? Polar ice, it's simple. Abigail, is water ice what we should be focusing on? Is that the thing? And if so, what don't we know that we need to find out? And if we need to broaden our horizons a little bit, what might we think about in terms of broadening our horizons?
Okay, if you were waiting for a response of yes or no, I'm sorry, I don't have that response. And I actually want to build off what Clive really nicely said. Right now, we can talk about many materials on the moon that have the potential to actually become resources. But still, we need to understand those materials, and we need to see what is the real potential, and then we can figure out which one will be the most useful to use at some point. And that means not only trying to go with instrumentation, with missions and things like that, but also we need to understand that data that they came back. And that is not just like, oh, I have these numbers, that is it, but it's more complex than that. We need, and probably Carlos will add, and we'll elaborate on that further, but it's like, before I can say this is what we should focus or not, we need to understand the potential of the different type of materials. So it's complex. I would like to say, yeah, let's go for this material or for this other, but unfortunately it's more difficult than that. I think there are a lot of potential. We saw a lot of really nice talks on lunar regolith for oxygen extraction, in rare earth elements, even in helium-3, in water ice, and I think all of them have potential. So why we should focus just in one? Why we cannot just actually study the potential of all of them? And when we know more about that, it's like, okay, right now, at short, medium, long term, these are the ones that are useful. So yeah, that is.
So as a mission planner, as an agency, trying to take decisions on what we should do, that's a terrifying prospect, because what the answer is all of the things. Yeah. So how might agencies, private sector actors and others, when looking at this enormous diversity of things that could be done, how do we start to take decisions about where we want to focus our efforts? Like, how do you do that given the status?
I mean, and also another question is like, not all the materials are in the same level of knowledge. So we have materials, I mean, we know that regolith exists on the moon. We have seen it, we calculate, we even measure some elements, some things, we know that. There are other elements that we suspect that they are there. We have quite relatively confident that probably there is there, but actually we don't know exactly where it is. So it's like the level of compromise of the space agencies, it doesn't have to be the same level for all the resources. You can try to make some missions like more specific to actually detect something, and other missions more broad, like actually to explore further. And also there is other materials that we can start trust private companies to do it. I mean, to study parts of the regolith, we actually have, we saw really nice talks from several companies that can start take care of that. So actually, I mean, I'm sorry to put in the space agency in this situation, but it's like, yeah, it's like you don't have to commit all to just one. You actually can, how you say it, when you put a little bit in many things, and also trust that the private industry and make the investor trust that this is potential and that this is good to do. So yeah.
Antonino.
If I may, James. I mean, that's where I think the coordinated approach can be a game changer, right? So as a single agency, of course, you need to define your priorities. You cannot pursue all the objectives, but you're not alone, right? There are other agencies that you can work with. There is the private sector. But what you're lacking right now is a holistic vision of how are we going to look at all these things at the same time with different resources. And so if there is an entity that you can go and discuss, okay, I am going to do water pollardized exploration, then I'm going to do regolith, then I'm going to do rare earth minerals. If there is a place that you can sit down and think about a coordinated campaign, that's where I think the added value of this initiative comes from. It's not just coordinating data about one type of resource, it's also expanding that and allowing different entities that have different interests to pursue them, knowing that others are thinking about the other aspects at the same time, and then you can come together and share the data that you got and take decisions as to what you actually want to do.
I think an important aspect is about the sharing. Yeah. So I'm happy for you to go and look at that, and I'll look at this, as long as I promise to show you mine if you show me yours.
Exactly.
And if we all believe each other, then we're okay.
Yes.
All right. So Carlos, so everyone goes out, we have these missions, and we generate all this data, and traditionally, our missions produce beautiful scientific data that like 3 people can look at and do something with, right? So unless you're specifically a data wonk and you just really like messing with that stuff, it's pretty impenetrable. So how do we turn all these data products that we generate into something that someone from the mining sector or who's involved in regulation or something that's not a scientist can find useful? What's needed to do that?
So, really good point. So, as a resource economist or a mine planner, how we call it in the mining industry, what we need are 3 main things, all right, to make really good use of it. And I presented really briefly on this, and I will be very simplistic. So first, you need your resource knowledge, and I'll come back to that. So we need to know the distribution of the concentrations and the tonnages related to these distributions. I'll come back to that. Second one, as I was mentioning, we need the value chain economics. We need to know the market. We need to know the operational cost, the capital cost, and so on. And the third one, we need to know the value chain constraints, your processing capacities, your yields, your extraction capacities. But I'll come back now to the resource knowledge. All this beautiful scientist data, science data, it's about translation. So how can we actually use it? So as a resource economist or mine planning engineer, we use block models. What is a block model? It's a 3D voxel model of your geological deposit, and it's turned into little cubes that have a volume, and it has all the elemental parameters, all the elemental composition, all the mineralogy, but it also has engineering parameters, like all your potential yields and all your potential extraction costs, all your potential values. And once you have all these engineering parameters, financial parameters, and your science turn into kind of geological parameters, now you have a geological, financial, engineering block model. Once we have that, we can start estimating reserves, running simulations, running all sorts of models, and then we can design potential mining scenarios. But long story short, we need to translate all this scientific data into something we can work and combine with all the engineering and the economical side of things.
Who can do that?
I can do that. S.a.r.l can help.
It wasn't supposed to be an advert, okay. Okay, but the point is that there is a step that is needed between what we traditionally do in terms of preparing missions, running missions, generating science data, analyzing data, and that data being useful externally. There's a step there where there are jobs for people to do to turn that science data into something useful, and that's something we also need to be investing in, I think is what I'm taking from that, from a prospecting perspective. Okay. Antonino, you talked a bit earlier about regulation. I think yesterday there was a point made about regulation. People tend to think that that's a scary bad thing. I was wondering if you could talk a little bit about, during this prospecting phase, what's really needed in terms of regulation, what kind of things we need to be preparing for the future, and why might that be a good thing?
All right, I'll try. Because being the lawyer in a panel of geologists and engineers, you can feel sometimes the tension. But I think we're getting better. Over and over the years at Space Resources Week, this is becoming accepted that we need some regulation as an enabler. This was said a lot yesterday. What do we need today in the campaign? I think we need an understanding of where we want to go and an understanding of how we're going to go and when. It's really about information sharing at this stage, because in order to avoid overlaps, we first of all need to be aware of where we're going. And there is a mechanism under Article 11 of the Aerospace Treaty through which states can share information on what they're doing so that they can all be informed. And then there is another mechanism under Article 9 of the Aerospace Treaty through which they can consult if they think there is something wrong. If they say, hey, wait a minute, I also want to go there, we should talk so that we avoid interference. This is what we already have. The question is operationalizing it. For that, we need streamlined practices. And that's some of the work that we're doing at the Lunar Policy Platform, is consulting with different governments, with different state agencies, even companies and scientists, and ask them, if you would be sharing information, how you want to do it. What do you need to share? What do you need to learn from the others? As you said before, I'll show you mine if you show me yours. What do you need to know from the others so that you can be safe? And therefore, what are you willing to share so that the others can get the same? That's the starting point. Now, as we progress with the prospecting, I think a key element is continue to inform the work of the United Nations. And what Stephen and his working group are doing is essential because it will define principles that hopefully will stay there for a long time. But in order for them to actually withstand the test of time, they will need to learn from this campaign. If we are fast enough and we can give them some information, that could have an impact on what the decisions will be taken on the principles. I think yesterday you asked this question at the regulatory session, right? Does it matter that we're doing all that? I think it does matter, and the member states in Corpus understand that it matters. Clive was there just a few weeks ago, and he told them about the campaign, and I think the feedback is we need to know more about it. So the question is, let's use the legal framework we already have in a practical and clever way to ensure that as we gain the data that we need to take certain decisions, we don't conflict with each other. And I think that's fairly straightforward. It could be done. And there is also an action team at the UN that is working on this. And then as we get this data, let's transform them into useful material for policymakers. So there might be a language issue there that we need to translate. What do they actually mean so that a policymaker can take it into account? And then once we have completed that initial phase in the next 2 to 3 years, then we can use that to produce more concrete rules about how much should a company be allowed to mine. This is still an open question, right? Can you go and mine an entire crater on the south pole of the moon? Is that something that others would consider legal? We don't know yet, but in order to take that decision informatively, we need to know if everybody can go anywhere. If there is enough resources in different craters, then yes, maybe you can get a crater. But if there is only a handful of craters that are useful or that we can operate with, then maybe you cannot get the entire crater. You will need to share it with others. So in order to take that decision, which is a policy and legal decision, we need to know what are we talking about. So we need to buy some time and get to the point in which we have the data and we have basic framework to take decisions and then apply them and see how they go. Because, you know, yesterday another concept that was mentioned was adaptive governance. These rules cannot be set in stone forever because at this point we again don't know enough. So we need to also be intentional and understand that we cannot write a binding treaty today because that would be counterproductive. We need to be able to have the rules that we need to evolve for the next 2 to 10 years, and then in 10 years' time we will be able to say, okay, we think we've done enough, now we can put some rules in stone. And I think that's the path that I see forward for the legal and regulatory aspect.
Cool, thanks. Clive.
My turn to follow the lawyer. It's, I just want to point out something you said, James, when Abigail said, well, there's a lot of resources, we need to be doing all of them. You said that terrifies me, and rightly so. But the whole point of this is no one agency can do this. No one company can do this. And it forces us in the finding to be collaborative and cooperative. That sets a precedent and a framework for when we get to the utilization to do the same. So if we can be collaborative, cooperative, and coordinated in the finding, we then set that precedent. And when you start to communicate and break down barriers, there's good things can happen. And I think that there is something that we've wrestled with is the idea of proprietary data. But in the finding, that's collaborative. Once we find a hot prospect and somebody goes there to really dig deep and find out just how much is there, that becomes proprietary. But we don't want it to become overly competitive. There's got to be a trust there, so there's got to be some part of that data that gets released so people understand what's going on in order to avoid conflicts and so on and so forth. That's where I think Stephen Freeland's working group is going to be most effective. And that's where we need the data to do that, because if you've got 3 PSRs on the moon that contain abundant water ice versus 3,000, the rules are going to be very different. And we need to know that before we move forward.
So I think that's a good point. And I would suggest maybe, would you agree that we're in a bit of a unique position at the moment in that today there is no market for space resources, lunar resources at all. What we're trying to do is to create an evidence base such that one day there might be one. And given that, we might have an opportunity at this point to collaborate in a way that we will never be able to do again, because there is no competition really. So maybe there's an opportunity there that we haven't seen yet.
And that's the opportunity for cooperation between different stakeholders and between different countries.
Okay. So did anything anyone wants to add before I ask you another question? Okay, so I didn't prepare you for this one. But, so I think we've established that there is a level of knowledge that we just don't have, but that we have to make all of the other stuff we're talking about here real. And the prospecting campaign of some sort is important. I think we've said, I remember like a few years ago, I personally knew absolutely everything that was happening in lunar exploration. Today, I haven't got a clue. There's just too much. That's amazing, and that's happened in less than a decade probably. We've gone from, someone's got a CubeSat to too many. It's amazing. So I think that's fantastic. With that, so many missions, there seems to be an opportunity for this collaboration that's something that we've never seen before. And actually, if we're going to do it, we have to do it now. What I would like to, from each of you, I would be interested to know, what might we do before next year that we could come back and say next year, we did a thing in each of those areas? What could we do as an action in each of your areas that you talked about by next year that we could come back and say, look, we did a thing, it's different now? Antonino, we'll start with you.
Start with the lawyer. I think the first step, and this is not really in the legal area, but what I understand from the situation, is really having that prospectivity maps, right? That I think phase 1 of the ILRPC, of the campaign, and therefore the consortium can do. So once we have a better understanding, evidence base of what's really there, with the data that we currently have, then we can use that as a starting point to plan more specific missions that will go and dig deep, as Clive said. And so that is, I think, what I would like to see at next Space Resources Week is maybe this same panel happening again, but with a prospectivity map in our backs, where we say, okay, we integrated the data we have, and this is where we think we should go next. And from my side, from the legal and governance side, I can tell you, if we have a consortium in place, that will help that to happen faster, and it will help to collect funding and interest for collaboration in designing a phase 2 mission that will go and do the ground truthing that is so needed to then enable the determination of reserves. And Stephen's working group will meet in a year's time, and hopefully they will be aware of that. And when they discuss again at the legal subcommittee, they'll be like, oh, last week at Space Resources Week, I found these prospectivity maps. There is tons of ice, potentially. They're going to go and check it out in a year's time. By 2027, before we finish with the working group, we will know if there is scarcity or not. That would be a major breakthrough that will change the way we do these rules.
Okay, so Abigail.
Yeah, I mean, it's really in the line of what Antonino just said. It's like not just maps. It's like actually we need to understand. I mean, resources is not a 2D material. Actually, it's a 3D. We need 3D modeling. We need to understand how those materials got there, how they vary, not just in geographical, but also with depth. So at this point, we don't have all that information. But we can see, it's like, okay, what information we have right now, and what we can do with this. And what we have, those 3D models, or these first maps, we can figure it's like, okay, now this is what we need to actually advance to the next level, that it will be the block models that Carlos will do for us.
Carlos.
Right. So what I propose is that this year we can actually involve the mining industry. And I know everyone is like, yeah, but how, right? Actually, in my previous life, we contacted one of the 3 major mining companies in the world, and they actually offered free expertise. They were like, we'll give you one of our exploration geologists to do some targeting, to choose targets on where to land and hit a resource, right? So we can actually involve the mining industry to get some experts on exploration to define the targets for the ILRPC. We can also involve the mining industry to help us to develop with them a block model, so it has the buy-in. And for them, it's no cost, and they have experts doing that. And then once we have the targets and the block model, we can now do an economic model and some potential reserves evaluations with themselves. So for them, it's just some hours of their experts, but then they are like, oh, tell me more about what you found. What's the value of it? What about those targets? So in that way, in a way, they are contributing with expertise as observers, but they have a chance to start having a buy-in. And it's achievable.
Cool. Clive.
I don't know what to add to that. I mean, the experts here have said it all. I would like to see an enabling attitude from the different disciplines here about moving forward together on this. It's my belief that this is the critical next step for space resources, starting at the moon. And we go forward together to do that. It sets a precedent for how to do asteroids, Mars, so on and so forth. Now, maybe that's a very utopian view. But we have the opportunity now because there is no money involved. There's no cash benefit yet. There could be, but we need those data. So we're at chicken and egg thing. We need to get those data products, so that we can then know where to go to get the granular data that's really going to show, is this all smoke and mirrors, or is this real? And I think we've been dancing around this for many years of, is this real? Because we're afraid it might not be. I don't think so. I think it's real, but we need the data to back it up, and this is a way to get it.
Thanks. So we've got about 5 minutes left, and I wondered if anybody here that I can't see at all, because it's really very bright here, has an opinion that they'd like to share. Again, I can't see you. I can see some hands, but it's going to be unfair because they're the people closest to us. So we'll start over here.
Hi, thank you for that. So it's been about 10 years since Wendy's article about the helium-3 incantation. We still don't have practical fusion for deuterium-tritium, let alone deuterium-helium-3, which is harder. So has anything changed in the last 10 years that should make us hope for a realistic lunar helium-3 market in the next 30, 50, or 100 years?
You must have missed Gary Lai's presentation today because it's quantum computing and detection for national security. That's the market. And that's how, is Gary here? I can't see, so you'll have to. I just answered it. Oh, okay. Thanks, Jerry.
Maybe one thing that I can add to this is like mining helium-3 versus mining water in a crater, it might have very different legal implications, right? Because if you mine regularly for helium-3, it's a much larger scale operation that could potentially have a lot of environmental consequences. I mean, I need to be more educated about it, but it's different than going into a crater that it's actually dark and nobody even see in terms of what do we do to the environment of the moon. But there will be a major difference. We just, no, Jerry, why not? There is. Abigail says yes.
Yeah, I think that there is. I mean, it's like the amount of helium-3 that can be taken
from a legalistic aspect, size shouldn't matter. It should be the process as long as you have the right guidelines with respect to environmental compliance, if there are any, then you should not discriminate on the size of the operation. You would discriminate on the impact potentially. So I think you're going to split hairs, and I think you're going to cause, butting heads of, well, I can do this versus I can't do that.
But size matters.
So I think that maybe, okay, so we have just a couple of things. I think first of all, prospecting is about creating information so that somebody else can decide whether they think there's a business case or not, right? So at the moment, helium-3, no idea. How much is there? Don't know.
Still want to know.
So if we know it's there, then somebody else who's none of us can take a decision whether they think it's worth investing in that, and maybe they're stupid and they lose, but that's their problem. I'm going to move on, just because there's not much time. I want other people in. That's the arms waving furiously. Go.
I've got the microphone, so I've got the longest arm. Hi, Stephen Freeland, and thank you for that wonderful presentation and also for your kind words. And looking from the perspective of trying to find this framework, your ideas just hit so many buttons, and if you look at the principles that I've drafted and now being considered, you can tick off almost every one of those principles with what you're doing. The crucial thing, I think, from the world that I'm trying to put together is the status of the data. You talked before, Clive, about non-proprietary data, and I think that's the really crucial issue, right? And so I want to understand a bit more from you. What is the status of this data? You're going to do amazing things. You're going to come up with great ideas. There seemed to be an underlying assumption in some of what you said that this data would be freely shared. But then there seemed to be another underlying assumption about, I'll show you mine if you show me yours. And so if you come up with this data and it is essentially widely shared and then people can make their mind, I think that's an incredibly positive step. If you come up with a model where you've sort of got to pay to play or whatever it is, right, in terms of the sharing of this data, that will encourage others to do similar things. Then it becomes counterproductive in one sense. Obviously, you're putting your consortium together, you're having investors or whatever it is, they want to make sure that they have the maximum benefit. But how will you really deal with this data sharing at the grassroots? Will you freely share it around the world? Will private entities within your consortium be happy that they're competitors? Will countries represented within your consortia be happy that other countries freely get the data, which is the source of your labour? Anyway, but it's a wonderful concept, and thank you again for supporting the multilateral process.
Can we maybe just very quick answer, and then we'll take one more question, and then I think we're going to have to close.
I'm going to give the answer that the data that we have from those missions are all publicly available that I listed. They are government missions, and they are freely available. The integration of those, and you raised the point that we've been wrestling with for a year, is how do we do the information sharing? All right, now, I now understand why nobody's tried to put this into place and has succeeded before, but we're working on it.
The key is the multi-purpose data policy that I was mentioning before, just to say that. It cannot be a one-size-fits-all. Some data will be publicly available, some others will not. And that's in the nature of things. It's already happening in the space industry, but some data, I can tell you, will be available.
As an agency, all of our data is public. This is a brave new world, and we don't have answers for all of that yet, but we are thinking about it. Yep. Last question.
Yes. Gustavo Medina Tanco from Links, UNAM. Just one practical question. If we all collaborate with our missions, by 2030, we would have 26 missions to the moon. So 26 tracks of a rover of 1 kilometer of length in a body of the size of Africa. What does it mean for information really useful to all this campaign and to transform resources in research, especially when there will be 26 different instruments that are able to measure only 26 different things with 26 different uncertainties? Thank you.
That's an excellent question, and that's why we need to coordinate and cooperate so we know where these missions need to go because of the data that we already have. And that's why we have this prospecting campaign, and it has to be international, it has to be cooperative, and it has to be coordinated for that very reason, so that we maximize the investments from individual entities that are doing missions to the moon. It's not just a mission, it's part of something bigger.
Very good. And with that, I think we're out of time. Thank you to all the panelists. Thank you to all of you.
Thank you.